Project management will help us to achieve our objectives. This is Ahmed Project and Risk Management Consultant, and we're still in our YouTube channel in order to promote project management. Our topic today, it's about the 3 points estimate, and it's one of the tools that we use in order to estimate the activity's duration more professional and more effective. Let's go to the outline. That's our outline for today. We have the 3 points estimate, and we're going to talk about a little bit about the schedule and the Monte Carlo analysis. The project schedule is one of the project baselines, and we have 3 baselines within the project, and we call them the triple constraints, and they are the scope baseline, the schedule baseline, and the cost baseline. What we use these baselines for, we use them in order to measure the project actual performance and compare it to these baselines in order to know if the project is under control or out of control. If the actual performance of the project falls within the baselines, then the project is under control. If it's not, then the project will be considered to be out of control. Developing the project schedule is happening during the project planning process. And in order to be able to develop the schedule, the project manager and his team, definitely the project management team, the PMT, they have to estimate the activity duration, as it is an important process to estimate the project duration and to be able to complete the network diagram. The network diagram, as a process, we are sequencing the activities, and after sequencing the activities, we need to estimate the activities duration in order to complete the network diagram, and then later on we will know what is the project duration throughout calculating the critical path. And definitely we can utilize the network diagram for other activities as well, such like determining the floats or knowing the critical path activities and the non-critical path activities. One of the characteristics of the projects that they are progressively elaborated. What does it mean, progressively elaborated? It means that throughout the progress of the project, we will know more about the project, and the project can be better defined, and the project definition will be clearer by the time. Why? Because we are progressing within the project. Why this happen? Actually, it happens because when we start the project with a very high uncertainty. And the uncertainty comes from the lack of information. We don't have enough information about certain topic, then we can call it's uncertain topic. Therefore, when we have uncertainty, we start setting assumptions. And these assumptions are considered to be source of risk for us in the project because they have to be proven right or wrong later on. But in order to be able to take decisions based on the uncertainty level that we have to set certain assumptions and to continue in the project and keep on making decisions. So the uncertainty at the very beginning of the project, it starts very, very high, but it starts to reduce throughout the project planning, executing, and monitoring and controlling processes. This requires the project manager and his team, the project management team, is to elaborate the project. Why? Because it's progressing and we are knowing more about it. So it means that there are certain updates has to happen to the plan, has to happen to the process, has to happen to the execution process. On the other hand, we have in this chart in front of you that the cost of change when we are starting the project, it is very low. But due to the risk exposure, the cost of change by the time we are progressing in the project, it will become high and high and high. Therefore, with a high uncertainty I'm facing in the project, and one of my baselines is the schedule, I should be selecting the proper tool in order to estimate the duration of the activities that's considered to be the input in order to determine the project duration. In order to be prepared for that uncertainty and how to tackle it in the project, we're gonna learn today one of the schedule development tools that we use in order to estimate the duration that will give us more flexibility in our duration estimation for the activities, where we're going to determine a lower limit and upper limit for each activity duration in order to be more flexible and more adaptive to changes, since we are dealing with uncertainties at the very beginning of the project. The schedules that we develop for our projects, they have a single value. Most of the schedules that we see, they have a single value. And that single value, we call it in the statistics, and we call it a management deterministic duration. It means that this duration was determined for that project and it's a single value. But unfortunately, that single value plan is for future events, and these events, they are inheriting certain uncertainty. Therefore, when we have a deterministic duration, we know that that kind of schedule is fixed and it has a high subjectivity, and we consider it to be unrealistic and less predictive. Why? Because the project manager is dealing with fixed dates, a fixed start, and a fixed end for every activity. Now, in small projects, this might not be a problem because we can still accommodate the actions, or we can still take certain actions in order to keep the project on track because it's a small project. But if we are in big projects, capital projects, then the element of controlling the deterministic duration uncertainty becomes very difficult, because in small projects you may have like 200 activities, but in huge projects you can end up with 15,000 activities, 16,000 activities. So you are engaging more uncertainty to the activities and adding these uncertainties to each other. Then the project is going to be unrealistic and less productive at the end of the day. Planning is all about predicting the future, so nothing is absolutely certain. Yet, ordinary deterministic schedule tools make no allowance for this. Therefore, the best thing we can do is to allow a single best guess duration for any activity. Such planning tools are described as deterministic because they determine single values for the scheduled dates. Normal or deterministic planning is useful for calculating a single end date for a project, but is unable to be used to find out how likely that date is to be achieved. Such planning activity is all too often misused to make a schedule fit a preconceived date, unless the plan is assessed by people knowledgeable enough about the time requirement to carry out similar projects, such like benchmarking, or who are familiar with the detailed execution strategy and duration of key tasks in the project. The flow basis of the schedule is often not apparent until the investment decision has been made and the execution is underway. Due to the preconceived dates, sometimes when we start planning the project schedule, we start constructing the schedule from the backward pass process, trying to justify a desired end date by squeezing activities duration and logic. Such an approach, ignoring the need for realistic contingency allowance and excluding the possibility of risk events occurring, is not only wishful thinking, but almost certainly doomed to fail. In the past and even presently, project proponents have relied on the additional of contingency as a rule of thumb, plus or minus 15, plus or minus 10%, to set more realistic targets, allowing for assumed levels of uncertainty of completing the project to the selected contingency percent. However, this method is crude at best and provides no legitimate justification for the calculated completion date incorporating such contingency. They may allow an over-generous contingency, or simply that completely it's not adequate. 3 points estimate is capable of addressing these issues by arranging each individual element within a schedule according to its inherent uncertainty. We are able to provide much more detailed and justifiable range of inputs. And if we would like to have more justifiable range of project completion, or more justification to the contingency, we can incorporate the risk events that we are planning and model them and see which of these risks are more potential to happen on the project, and we simulate them. Then we'll have more applicable and realistic schedule. How the 3 points estimate will help me in developing a realistic project schedule. It will help me throughout finding out how likely the completion date to be achieved. When I have 3 points estimate, I'm going to have the lower limit and the upper limit of the activity's duration, and from there I will know how likely to achieve the activities or to achieve the project within the given estimation. Moreover, it will help me to reduce the common schedule planning challenges where I'm determining the duration of the activities, and that's actually trying to get rid of the magic date syndrome. Also, if I would like to go farther in utilizing the 3-point estimate, I can also utilize the risk events and make them part of my project schedule planning process, and then later on simulate the schedule throughout using certain softwares and certain principles such like Monte Carlo, that will provide me a mathematical justification for my project. It will help me also to expose the major determinants of the uncertainty that I have within my schedule, especially when it comes to the duration. Why? Because when I'm planning the 3 points estimate, I'm determining what's going to be my pessimistic and what's going to be my optimistic. And based on the pessimistic and the optimistic and the most likely, I will be tackling and addressing all the major uncertainties that I have within my scheduling or within my planning activities. Why 3 points estimate is important and why simulating the schedule is important? Let's take a quick look into the figure in front of us. If we have activity A, activity B are the predecessors of activity C, it means that activity C will never be starting unless activity A and activity B are completed. So the magic question is, what is the probability to complete activity C on time? The test over here, we need to finish activity C on time. So activity A and activity B has to be completed on time. So activity C will start on time and it will finish on time. So what are the scenarios that we have within our project? The first scenario is that activity A is on time, activity B is on time, so activity C will be on time. The other scenario is that activity A is not on time, but activity B is on time, then activity C will never be on time. Why? Because activity C will never start unless both activities A and B are completed. And the third scenario that we have that activity A is on time, but activity B is not on time, then activity C will not be on time. Why? Again, because activity C will never start until both activities A and B are completed on time. And the fourth scenario is that activity A is not on time and activity B is not on time, and definitely C will never be on time because none of the predecessing activities has been completed on time. So if we have 4 scenarios, and if you consider that each one of them is having a percent, and if you calculate the total percent, it will be 100, so 100 over 4. So the probability of completing activity C on time is only 25%. That's why the 3 points estimate and the project schedule simulation will help us to have a mathematical justification to the project completion schedule and how realistic is our schedule. What is PERT? PERT is acronym. If you spell it out, it will be Program, Evaluation, and Reporting Technique. And we use the 3 point estimate in order to complete the PERT analysis. What are the 3 points? The 3 points are the good duration, the bad duration, and the normal duration. In another word, the completion duration that happened in good days and the duration of an activity that happened in a bad days, and what normally this activity will last in order to be completed. How we have the good days and how we have the bad days. The good days, we have them from having opportunities happening within the project, and this is actually what will be defined in risk management, that we have positive risk as well, which is generated from an opportunity that will have a positive impact on our project. So the good days are generating from opportunities happening, and the bad days are from the threats that they are happening within my project. And the normal day is the mix between the good and the bad. We have opportunities happening and we have threats happening, but the threats are eating the opportunities or the opportunities are eating the threats. Then we're going to have the normal duration of an activity to be completed. In the 3 point estimate equations, we don't use good days, bad days, and normal days. What we use actually is pessimistic, optimistic, and most likely duration. The pessimistic will be indicating the indicator for the bad days. Optimistic is going to be the indicator for the good days, and the most likely is for the normal days. 3 points estimate, it has 2 formulas. We're going to start with the first formula, which is the triangular estimation. With the triangular estimation, since we have 3 points, we're going to calculate the average or the mean of these 3 points, which is pessimistic plus optimistic plus most likely over 3, and this will give us the estimated duration for an activity based on 3 points estimate. So let's have the schedule in front of us, activity A and B and C, and let's say that these activities they have no dependencies, or they are not on the network diagram. So we're not developing the network diagram as much as we are just only calculating the PERT analysis, or we're conducting PERT analysis for these activities. So activity A has an optimistic optimistic duration of 10 days or 10 months, while the activity A has a most likely duration of 15 and a pessimistic duration of 18. So if we use the formula in order to calculate the PERT, we conduct the PERT analysis in order to calculate the duration of the activity A through our PERT analysis. It will be 10 plus 15 plus 18 over 3. That will be 43 over 3, and that's going to be 14.33. Let's do the same for activity B, where it has optimistic 10, most likely 12, and pessimistic 16, and that will be 10 plus 12 plus 16 over 3, 38 over 3. That will be 12.67. So the PERT duration for activity B will be 12.6 months. Now I'll pause the video and calculate for us C. Correct? The answer for C will be 21 plus 25 plus 31, which is the optimistic, most likely, and the pessimistic. That will be 77 over 3, and it will be 25.67 months, weeks, days, whatever the time unit I'm using. Moreover, there's another equation that we use in order to conduct PERT analysis using the 3-point estimate. We call it the beta estimation. What happened actually is that the most likely is the most likely to happen within the project. So most likely should have more weight than the pessimistic and the optimistic. And since we have pessimistic and optimistic, which is 2, if we would like to double it up to give more attention to the most likely, then it will be 4 most likely. And now since we have 6 variables, which is the 4 M's plus the O plus the P, so the average should be calculated over 6. We still have the same schedule and the same table, and we would like to calculate the beta estimation for the activities. So activity A, duration will be 10 plus 4 times 15. 15 is the most likely to happen, so it's going to have a double weight over the other 2 variables, plus 18, which is the pessimist, and this time it's not going to be over 3, it will be over 6 because I have 6 variables, and that will be 88 over 6, and that will be 14.67. Let's do for B. B, it will be equal 10 plus 4 times 12. 12 is the most likely to happen. We're going to give it more weight from the other variables, so it's going to be 4 times 12 plus 16, and again we're going to divide it over 6 because we have 6 variables, and that will be 74 over 6, and the answer will be 12.33. Now pause the video, calculate C duration. Correct. It's 21 plus 4 times 25, which is the most likely, plus 31, which is the pessimistic, over 6. It will be 152 over 6, and the answer will be 25.33. So far what we have done, again, we have determined a single value for the activity, and that's what we did not. That's different from what we have started earlier by saying that we need more flexible, we need lower limits and upper limits for the activities in order to have more realistic schedule. We did not finish yet the PERT analysis. We just only calculated a single point for every activity throughout doing the 3 points estimate and having the average. In order to complete the PERT analysis and the 3 points estimation, we need to calculate the standard deviation. What's the standard deviation? Standard deviation is the correction figure or the correction factor that we will use in order to adjust the duration. We have 3 points, or we have 3 durations for every activity: optimist, pessimist, and most likely. So we need to set a standard deviation or a correction figure that will help me in order to come up with a realistic duration for my activities. And the formula is P minus O over 6. P is the pessimistic, O is the optimistic, and 6 is just number 6, and we use that in order to determine the 6 sigma of my duration. So let's start calculating the standard deviation of activity A. The pessimistic is 18 minus 10 over 6, and that will be 8 over 6, and it will be 1.33. B standard deviation equal pessimistic is 16, optimistic is 10, over 6, and that will be 6 over 6, and that will be 1. Now please pause the video, calculate the standard deviation of activity C. Correct. The standard deviation of activity C is 31 minus 21 over 6, which is 31 is the pessimistic and 21 is the optimistic of duration of activity C, over 6, and that will be 10 over 6, and my standard deviation is 1.66 for activity C. If we look into the standard deviation now, 1.66 is considered to be the highest standard deviation among all the other activities. The other one is 1.33 and 1.66 is the highest standard deviation. What does that mean? It means that activity C has a high risk or risk potential activity because it has the highest standard deviation on my schedule. Why? Because the variance between the pessimist and the optimist is a long range, and you can see that from the calculation down there, that activity A has only a variation of 8, where the B has a 6, and C has a very long range between the pessimist and the optimist, and that's 10 days, months, or week, which let's call it 10 months. So it's going to be 10 months, which is greater than the 8 and the 6, so it has a higher standard deviation among all the other activities, so it's considered to be a risk potential activity. Now let's complete the PERT analysis using the 3 points estimate, and now PERT analysis says that the PERT number that we have, which is the average from the triangle or from the beta, has to be plus or minus the standard deviation. How it will be calculated, we still have the same table, but I have included the activity A, B, and C. We have the triangular duration and we have the beta duration. And let's calculate first of all the triangular duration for the time estimation using PERT analysis for the triangular duration, and that will be 14.33 plus or minus 1.33, which is the standard deviation of the activity A, and it will be ranging from 13 to 15.66. So this activity A has a range of duration from 13 months to 15.66 months. 13, it's the lower limit. 15.66 is the upper limit. It means that less than 13 months, it will never be completed. And 15.66, it means by that time, that activity has to be completed as per the triangular analysis. Let's calculate B. B, it will be 12.67 plus or minus 1. My standard deviation is 1 for activity B, and it will be 11.67 to 13.67. It means that this activity has a range of duration from 11.67 months to 13.67 months. It means that less than 11.67 months, this activity will never be completed, and 13.67, it means that by that time the activity has a probability of 99.9998% to be completed. Pause the video, calculate the time estimation using the PERT plus minus standard deviation for activity C. That's right, the triangular PERT for activity C is 25.64 plus or minus the standard deviation, which is 1.66. So the duration of activity C will be 23.98 till 27.3. It means that less than 23.9 months this activity will never be completed, and by the time the 27.3, by that time the probability of completing that activity at that time it's 99.99998%. But what about the 25.64? Let's say with activity C. What's the probability of completing activity C with 25.64 months? The probability is 68.78%. So the probability of completing the activity with the 25.64 duration that we have calculated from the PERT, from the 3 points estimate, it will be 68.69%. Now let's calculate the PERT analysis using the beta formula and the duration for A as a beta formula is 14.67 plus or minus 1.33, which is the standard deviation, and this activity will range between 13.34 up to 16 months. So that's the duration of the activity based as a lower limit and upper limit. Less than 13.34, the activity will never be completed. There's a 99.99998% that this activity will never be completed by that time. And the 16, it means that 99.9998% this activity will be completed. So let's calculate B activity, and beta duration is 12.33 plus or minus 1, and that will be 11.33 and 13.33. Pause the video, calculate C. C, 25.33 is the beta duration plus or minus 1.6, which is the standard deviation, and the duration will be 23.67 up to 26.99, and that's again the duration, the upper limit and the lower limit of activity C. And the 25.33 and the 12.33 and the 14.67, which is the beta calculation, the probability of completing the project on beta calculation is 68.79%. This is usually how the PERT analysis, the 3-point estimate, is presented for the activities. We see that it is a range between 13 to 15.66. I believe that these are the numbers of activity A throughout the triangular analysis. So the range is between 13 to 15.66. That's the lower limit and that's the upper limit. And here we have on the 13, we have a 99.9998%, which is 6 sigma, that this activity will not be completed by that duration. And the 15.66, it means that 99.9998% this activity has to be completed by that time, where the 14.33 is the average duration to complete the activity, and the probability is 68.79%. I have a good news for you over here, which is that the 3 points estimate, it's a tool that we use in order to estimate the schedule or to estimate the activity durations. As well, we use it in order to estimate the activity cost. So that's a good news. So when you start your PMP exam preparation, you will find that the same tools that we use in order to estimate the activity duration, we are using them in order to estimate the cost as well, the activity cost. Let's take an example over here. Activity A, it has an optimistic cost of 100k, and the most likely $150k, and the pessimistic is 210k. And if we use the formula, we will calculate and see that activity A is having the 10k plus 150k plus 210k over 3. That will be 153.33k. Similarly, we can also perform the beta analysis. This is the triangular analysis. We can use also the beta formula by saying that the pessimist plus optimist plus 4 most likely, but this time it has to be over 6, and you will have the same same results or same process that we have done for the schedule or the activity duration estimate. It can be also conducted for the cost as well. This is the 3 points estimate, PERT analysis 3-point estimate. It will give us a lower limit and upper limit for every activity, and that's going to be an interval. Instead of having a single point or single date for an activity, we will have now a range of duration for a single activity, which will have a lower limit and upper limit, and it will have the average in between, or the 68.79% of probability of completing the project within the completing the activity within that duration. Now the question is, can we draw the network diagram using the 3 points estimate? Unfortunately, the project schedule network diagram cannot be drawn using the 3 points estimate. Then why we need the 3 points estimate? We need the 3 points estimate in order to determine the project probabilistic schedule and cost completion at any time, at any cost. So by performing the 3 points estimate, it will help us to evaluate the total completion date of the project. It will help us to determine the realistic schedule and realistic budget for the project throughout using the 3 points estimate. Again, I'm telling you, not every project requires us to requires to perform 3 points estimate or PERT analysis for it. If it's a small project, we said project management methodology, it's adaptive. We can adapt all the processes and it's flexible. But if you are in a huge and capital project, you have to perform the 3 points estimate and do the PERT analysis in order to know what's your probabilistic schedule and cost completion of the project, and also to determine what are the contingencies that you need. If the project schedule network diagram doesn't work and doesn't help us, and we cannot represent this 3 points estimate into it, so how we can scientifically or how we can mathematically prove to the management that the project schedule and the project budget they are as realistic as our finding from the PERT analysis. In order to do that, we use a tool called Monte Carlo analysis, where Monte Carlo, it's a mathematical technique based on a random calculation, and it's a computer software that simulates the project schedule and the project budget throughout multiple iteratives. Virtually, it conducts the project 5,000 times, 1,000 times. We simulate the project based on a random calculation, and then the results are presented on a chart, and that chart will tell us this is how we're gonna prove it to the management that the mathematical answers are telling us that this is going to be our realistic schedule. These are the confidences that we have in our schedule and in our budget, and this is the probabilistic schedule and cost completion of the project at any time, at any cost. Moreover, mainly the Monte Carlo analysis is associated with the project risk management outputs and throughout the quantitative risk analysis. That's why we advise not to simulate the schedule and simulate the budget without performing project risk management, because project risk management will give you more realistic schedule and cost completion to your project. This is how the chart will be presented after we perform Monte Carlo analysis. If you look into the chart, you will see that we have 5,000 trials. It means that frequency, we have simulated this project 5,000 times. We have simulated the schedule 5,000 times. That's on the right side. On the left side, you will see that we have 0.00, which is 0%, 25%, 50%, 75%, and 100%, which is the one. And in between, we have the S curve. This is called the S curve because it looks like an S. Now, if I ask you the question, what's the probability of completing the project on the 28th of January? And if you look into the chart and draw your lines, you will find there is a probability of 50% to complete the project. So what's the probability of completing the project on the 10th of February? If we draw the line, we will find that it is 100%. So it will give us the probabilistic schedule and cost completion of my project. Moreover, from having the Monte Carlo analysis and performing quantitative risk analysis, project managers are capable to determine the contingency required in the project when it comes to the schedule and when it comes to cost. Unfortunately, this is the end of our video today, but still it's not the end of project management on our YouTube channel. Remember to subscribe, like, as well as pressing the notification in order to receive the new videos, and follow the links below in order to know how we can help you to prepare for the PMP exam.